I want you to imagine something. Right now there's an object moving away from our sun at over 130,000 miles per hour. An object that has been traveling through darkness between stars for possibly 12 billion years. It existed before our sun was born, before Earth formed, before anything in our solar system came into being. And 6 days ago, as it reached its closest point to our sun, it did something that has left astronomers completely baffled. Something that shouldn't happen according to everything we know about comets. What if I told you this visitor from interstellar space just displayed behavior our models can't explain? That it suddenly became twice as bright as predicted, exactly at the moment it passed closest to the sun? That it's losing water at 40 times the rate it was just 1 month ago? And here's what makes this truly unsettling. It has no dust tail. Every comet we've ever studied produces dust. But this ancient traveler looks nothing like what a comet should look like. They're calling it 3 Atlas. And we have maybe a few weeks left to figure out what it really is before it disappears back into cosmic darkness forever. Because once it's gone, we'll never see it again. And what we're discovering is forcing scientists to consider possibilities they never wanted to consider. On October 29, 2025, as 3I Atlas approached perihelion, astronomers Chi-Chang Jiang and Carl Bay-Toms were watching. They expected brightening as it got closer to solar heat. Standard comet behavior. Except what they witnessed wasn't standard at all. The brightness didn't just increase gradually, it exploded. The rate doubled instantly, twice as fast as before. They had no immediate explanation for what they were seeing. The spectrum analysis revealed something deeply strange. The comet's light became bluer than the sun's own spectrum, indicating carbon molecules and amidogen compounds, signatures of active ice sublimation. But radio observations detected that in just 2 weeks before perihelion, 3 Atlas was losing approximately 5.7 times 10 to the 28th power water molecules per second. That's 40 times more than 1 month earlier. Like a fire hose on full blast. Space-based telescopes SOHO Stereo A and GOES 19 captured images during this critical period. What they saw was deeply anomalous. The comet appeared as a faint, elongated spot but had no visible dust tail. Just this stretched-out glow without the characteristic dust trail every comet produces. Where is the dust? As ice sublimates, it carries dust particles, creating those spectacular tails. But 3 Atlas shows primarily gas emission. The hydroxyl glow from water vapor, but almost no dust. Some scientists proposed an explanation. Initially, carbon dioxide gas was escaping at about 3 astronomical units, cooling the surface and acting as a protective layer preventing water sublimation. Then something changed. That protective layer depleted, and water ice underneath was suddenly exposed to direct solar radiation. The result was explosive brightening. That's plausible, but it doesn't explain everything. There's another possibility that makes researchers uncomfortable. The composition of 3I Atlas's nucleus might be fundamentally different from anything we've seen. Remember, this object didn't form in our solar system. It formed around a different star, in a different stellar environment, with different chemical conditions. What if its internal structure is nothing like the comets we're familiar with? The James Webb Space Telescope observed 3 Atlas, and what it found adds another disturbing layer. Webb's near-infrared spectrograph revealed this comet has been transformed by billions of years of cosmic ray bombardment. Galactic cosmic rays, high-energy particles permeating interstellar space, striking the surface continuously for eons. Research led by Roma Maggiolo from the Royal Belgian Institute for Space Astronomy shows these cosmic rays have fundamentally altered the physical and chemical structure of 3-Atlas computer. Simulations suggest cosmic rays penetrated approximately 50 to 65 feet deep, creating what scientists call a deep irradiated crust. This crust no longer resembles pristine material from the comet's home star system. It's been cooked by radiation so long it's become something else entirely. Scientists hoped interstellar objects would give us a window into other stellar systems, allowing us to analyze pristine samples. But if Maggiolo is right, what we're looking at isn't pristine. It's a heavily modified, radiation-processed shell fundamentally changed by its journey through interstellar space. Maggiolo said 3I Atlas is now a product of its interstellar journey rather than where it came from, at least on the outside. This raises a critical question. What's underneath that irradiated crust? What's hidden in the core that might still be pristine material from its origin system? And here's something most people don't know. Professor Avi Loeb, former chair of Harvard's astronomy department, has formally requested that NASA release all scientific data on 3-Atlas to the public. Why? What does he think might be in that data NASA hasn't shared yet? Scientists admit they don't know what will happen next. Will brightness continue increasing? Will it suddenly fade? Jang and Badams noted the comet's evolution after perihelion could be just as unusual as the outburst that preceded it. Maybe more unusual. We're watching in real time as an object from beyond our solar system does something we can't fully explain. The trajectory of 3-Atlas is unusual. It's moving in what observers describe as an unusually flat and straight path. This isn't the chaotic curved trajectory you'd expect from an object that formed in our solar system. This is a trajectory that screams, I came from somewhere else and I'm just passing through. Some estimates suggest 3-Atlas could be 7 to 12 billion years old. That would make it approximately 3 billion years older than our entire solar system. This object existed before our sun ignited, before Earth formed. It has been traveling through the galaxy since a time when the Milky Way looked completely different. What has this object seen? What environments has it passed through? What stellar systems did it drift by in the darkness? We don't know where it formed, what star it orbited, or what happened to that star. We don't know if it was ejected from a young planetary system, or if it simply condensed in space between stars and has been wandering ever since. What we do know is that right now, 3-Atlas is moving away from our sun, heading back into darkness. And we have a limited window to gather data before it fades forever. Once it leaves, we'll never see it again. This is a one-time opportunity. Loeb has been vocal about the need for transparency with interstellar objects. He was one of the leading voices calling for serious investigation of Oumuamua, the first confirmed interstellar visitor in 2017. Loeb argued Oumuamua's elongated shape, its unexpected acceleration, and its lack of visible comet activity were anomalies deserving rigorous investigation rather than rushed explanations. Now with 3-Atlas, Loeb is calling on NASA to release all scientific data to the broader research community and public. His argument is straightforward. This is an object of extraordinary scientific importance, only the third confirmed interstellar visitor we've ever detected. That data shouldn't be siloed. It should be available for independent analysis by researchers worldwide, but there's an unspoken question underneath Loeb's request. What exactly is in that data? What has NASA observed that hasn't been publicly discussed? The scientific community is divided. Some researchers are comfortable explaining it's simply a comet with unusual composition, modified by cosmic radiation, behaving in ways we haven't seen, because we've never studied an interstellar comet this closely. They point to carbon dioxide, water vapor, molecular signatures that say this is a comet, just a weird one, but others are less certain. They point to anomalies, the explosive brightening that doesn't match models, the missing dust tail, the perfectly flat trajectory, the possibility its internal structure is fundamentally different from anything in our cosmic neighborhood. And they ask quietly, what else could explain these observations? No one is saying it outright. No one wants to jump to conclusions without evidence. But the questions are there. What if 3I Atlas isn't entirely natural? What if there's something about its composition, structure, or behavior suggesting it's more than just ice and rock drifting through space for billions of years? Here's what makes that question uncomfortable. We have no framework for answering it. Our entire understanding of comets and asteroids is based on natural formation processes. We look at spectra, see carbon dioxide and water, and think comet. But what if the signatures we're trained to interpret have multiple possible explanations? What if some things we're seeing could be consistent with both natural and artificial origins? How would we even know the difference? Our sample size for interstellar objects is exactly 3, Oumuamua, Borisov, and 3 Atlas. 3 objects out of potentially billions drifting through our galaxy. We're drawing conclusions about an entire class of cosmic phenomena based on 3 examples. That's not science. That's preliminary observation, and each has presented surprises. Oumuamua accelerated in a way that couldn't be explained by outgassing alone. Borisov was relatively normal but came from a different stellar environment. And now 3I Atlas is brightening explosively, losing water at unprecedented rates, challenging our models. The explosiveness of 3I Atlas's brightening, the timing, the way it happened right at perihelion, that keeps nagging at researchers. Some have noted the timing, coinciding almost exactly with perihelion, seems too precise. Natural processes are often messy and chaotic, with gradual changes rather than sudden transitions. The scientific explanation is a threshold effect. As the comet heated up, it reached critical temperature where sublimation rate suddenly increased. The protective carbon dioxide layer depleted at a specific point, exposing water ice all at once, leading to rapid brightening. That's plausible. But there's an alternative interpretation. What if the object was designed to activate at a specific distance from a star? What if the outburst wasn't caused by passive heating, but by some internal process triggered by proximity to our sun? Before you dismiss that as science fiction, consider this. We've already sent probes that activate at specific times or under specific conditions. The concept of a threshold-triggered system is basic engineering. What makes 3I Atlas particularly intriguing is its mass. Early estimates suggest approximately 33 billion tons. That's enormous. Halley's Comet is estimated at around 22 billion tons. So 3I Atlas is significantly more massive than one of the most famous comets in history. Combined with other anomalies, the high velocity, explosive outgassing, unusual trajectory, it adds another data point to a growing list. And the velocity itself, 130,000 miles per hour, represents a specific energy state. This object is moving fast enough to travel between stellar systems over billions of years. It's been in transit so long the star it originated from might not even exist anymore. Think about that journey. 7 to 12 billion years. This object has been traveling since before complex life existed on Earth. It survived encounters with stellar systems, gravitational perturbations, radiation from sources we can't identify. And it emerged intact, still coherent, still recognizable rather than a dispersed cloud of debris. The irradiated crust Webb detected might be part of the answer. That 50 to 65-foot thick layer could be acting as protective armor, shielding the interior, maintaining structural integrity. A shell forged by billions of years of cosmic ray impacts. In a sense, the journey itself made 3E Atlas more durable. But here's where it gets interesting from an engineering perspective. If you were designing a probe to travel between stellar systems, to survive the harsh environment of interstellar space for billions of years, what would you do? You'd need radiation protection, structural integrity against micrometeoroid impacts, a design handling extreme temperature variations, and you'd probably want it mostly passive, not requiring active systems for most of the journey, only activating when encountering specific conditions. An irradiated crust would serve many functions. Protect the interior. Provide structural strength. Be formed naturally by the environment, requiring no active maintenance. And if there was something underneath, something needing to remain dormant until triggered by proximity to a star, that crust would keep it safe. I'm not saying that's what 3E Atlas is. I'm saying if you look at the characteristics we've observed, the age, mass, protective crust, threshold-triggered activity, you're looking at properties that would also be consistent with a designed object meant to travel between stars. That doesn't prove anything. It just means we should be thorough in our analysis. The observations coming in over the next few weeks will be critical. If 3I Atlas fades predictably, if its behavior matches refined models of irradiated comets, then we'll have a good natural explanation. But if behavior continues deviating from predictions, if there are patterns in activity that don't correlate with solar distance, if spectroscopic data reveals compositions or structures challenging our understanding, then we'll need to expand our hypothesis space. That's uncomfortable for many scientists, because once you start entertaining hypotheses outside the conventional framework, you open yourself to criticism, accusations of speculation, being labeled fringe or sensationalist. But that discomfort shouldn't prevent us from following the data wherever it leads. Loeb has argued repeatedly that the stigma around discussing non-natural origins for unusual objects is itself unscientific. Science is supposed to be agnostic about outcomes. You propose hypotheses, test them against evidence, follow the results. If an artificial origin hypothesis can be tested and falsified, then it's valid scientific hypothesis, regardless of how uncomfortable it makes people. We are living in a moment of cosmic significance. For the first time in human history, we have technology to detect, track, and analyze objects from other stellar systems. The James Webb Space Telescope is giving us unprecedented insights. Our network of space-based observatories provides continuous monitoring ground telescopes alone could never achieve. This is the golden age of interstellar object research, but it's also a brief window. These objects pass through quickly. 3 Atlas will be gone within months, disappearing back into vast emptiness between stars. We may never see another interstellar visitor for years or decades. Each one is precious. Each one is an opportunity we can't afford to waste. The next few weeks will tell us a lot. As 3 Atlas moves away from the sun, as we continue monitoring its brightness, spectrum, trajectory, we'll gather more pieces of the puzzle. Maybe those pieces will fit together into a clear picture of an unusual but entirely natural comet. Maybe they'll reveal patterns that challenge our current understanding and force us to expand our theories. Or maybe, just maybe, they'll show us something we weren't expecting. Something that makes us question our assumptions about what's possible, about what exists out there in the darkness, about whether we're as alone as we've always believed. One thing is certain. We're watching. Right now, telescopes around the world and in space are pointed at 3 Atlas. Scientists are analyzing spectra, calculating trajectories, modeling internal structures. The data is accumulating. The picture is becoming clearer. 3 Atlas came from somewhere. It traveled for billions of years to reach us. It survived conditions we can barely imagine. And now, for a brief moment in cosmic time, it's here. Close enough for us to study. Close enough for us to learn from. It's behaving in ways we didn't predict, revealing properties that force us to think harder about what interstellar objects really are. The question isn't whether 3 Atlas is strange. It clearly is. The question is what that strangeness means. Is it the strangeness of a natural universe more diverse and complex than we've given it credit for? Or is it the strangeness of something else? Something that makes us reconsider fundamental assumptions about our place in the galaxy? Time will tell. The data will tell. And that's why we need all of it. That's why transparency matters. That's why Loeb's request to NASA is important, regardless of what the final answer turns out to be. Because in the end, this isn't just about one object passing through our solar system. It's about how we approach the unknown. It's about whether we're brave enough to follow the evidence wherever it leads, even if it takes us to uncomfortable places. It's about whether we're willing to ask difficult questions and accept uncertain answers. 3. Atlas is still out there, moving away from us, carrying its secrets back into the darkness. But for now, for these precious weeks while it's still visible, we have a chance to learn, to observe, to question, to wonder, and maybe, just maybe, to discover something that changes everything. The universe is speaking to us through these objects. Are we listening carefully enough to hear what it's saying?